Hello students, welcome to Narang College online classes. So in the last class we have completed ionic bond and factors affecting the formation of ionic bond and the properties or characteristics of ionic bond or we have discussed. Clear? So the next bond is dative bond or coordinate bond. Clear? So I already know that. And the covalent bond is formed by the sharing of electrons. One atom will give one electron, another atom give another electron, and they share these two electrons and form a one bond. And that bond we will call as a what it is known here, covalent bond. Yeah. So ionic bond we have already discussed. Ionic bond what it is? Complete transfer of electrons. Clear? The bond is formed due to the complete transfer of electrons is called as a ionic bond. But here dative bond is different. So what it is here, dative bond, one atom means you know that in the covalent bond, one atom give one electron, another atom give another electron. These two electrons form one bond. That is covalent bond. But in this coordinate bond, one atom only give the two electrons. What we want here? One electron only gives the two electrons, and both the atoms will share those two electrons. Clear what it is? So one atom provides two electrons, pair of electrons, and but those pair of electrons are shared by both the atoms. Clear? In order to get octet. Clear? So the bond formed we will call is what it is known here, coordinate bond, and can also be called as a what it is known here, dative bond. Clear? See, this is the one heading and means definition of the dative bond. What is the dative bond here? See, it is a kind of covalent bond in which electron pair is donated by only one atom. Two electrons are donated by only one atom, but shared by both the atoms in order to complete their octet. And the bond formed is called as a coordinate bond. Clear here? This is about the definition of coordinate bond. Clear? So now in this one, the coordinate bond is represented by arrow. What it is known here? Coordinate bond or dative bond. This can also be called as what is known here? Dative bond is represented by arrow. If there is a arrow, single arrow, clear here? So that bond we will consider as a what it is known here, coordinate bond. If single bonds are there and if it is bond is there, it can be a covalent bond or it can be a ionic bond. But here this arrow is there, then the bond is what it is known here, dative bond. Clear? And here I mentioned here one atom donate the pair of electrons. Two electrons are pair of electrons means what is it? Two electrons. One atom means one bond formation, how many electrons required? Two electrons required, and the two electrons are given by only one atom. And the atom which donates the electron is called as a donor atom. The atom which accepts those electrons is called as a acceptor. Clear? That I will discuss here. So now, if I take one example, you can easily understand what is this dative bond. Clear? And I will write here one example. I will write here NH4 plus. In this NH4 plus, there is a dative bond. Clear? So how it is? You know nitrogen. What is the nitrogen central atom here? What is nitrogen? Because you know hydrogen it is never act as a central atom. So nitrogen means you know what? How many valence electrons are there in the nitrogen? Nitrogen is belongs to fifth group, so that's why there will be a 5 valence electrons on the nitrogen. Clear? So that's why you know. And this is nitrogen, and 2s2 and 2p. Clear? 3. 1, 2, 3. This is the valency configuration of nitrogen. Clear? Nitrogen can form how many bonds, covalent bonds here? Only 3 bonds. Why not? I already mentioned. Unpaired electrons only participated in the bond formation. Clear? So that's why nitrogen will form how many bonds here? Nitrogen will form 3 bonds. So that's why nitrogen is forming 3 bonds with the 3 hydrogen. Clear? Now you know that nitrogen is having one lone pair of electrons. This is non-bonding electrons, or can also be called as a lone pair electrons, not participated. So here nitrogen is having what it is my here, one lone pair of electrons. Clear? Now plus if there is electron deficient compound, H plus is coming. What is coming my here? H plus is coming. Now you know that hydrogen will have how many electrons? Single electron. But H plus means that electron is lost. So hydrogen doesn't have any electrons here. Clear? So that's why what happened here. This is electron rich because it is having pair of electron here. It doesn't have any electrons, so that's why it donates its pair of electrons to hydrogen. Clear? Then what will happen you see? And that I will write here, there is a hydrogen, hydrogen and hydrogen. Clear? So now this pair is, this is H. Clear? I will write this is unpositive. Clear? So this is because here positive, you know that here this nitrogen is giving electron, means nitrogen is losing electron. So that's why the charge should be on which one? Nitrogen. So we will write that is a overall charge. The charge is not actually belongs to nitrogen and hydrogen. Overall charge we will write. Clear my dear? So this is N and 4 hydrogen charge. Now you see here in this case nitrogen it completes its octet. How much? You here 2 electrons. One bond means how many electrons? 2 electrons. Totally how many electrons are there here? 8 electrons are there. And the hydrogen also, you know, it reached the doublet. Doublet means you know what it is one. It is a stable. Clear? So one is means here you see. Observe in this case only one atom is donating electron. One atom only donating electron. But that electrons are shared by both the atoms. The electrons are shared by both the atoms in order to get the octet. But in case of hydrogen, it is what is not doublet. So this is, and the bond formed here, we will write simply what it is not here, hydrogen, hydrogen, and hydrogen, and this bond we will represent it as a which one here. So this bond we will call as a what it is not here, negative bond. Got my point here? So this is another example. If I take another example, I will take here water molecule. Clear? If I take here water H2O. H2O means you know, and this is hydrogen and hydrogen. So oxygen will have how many lone pair of electrons? 2 lone pair of electrons. We can write how to write the Lewis structures. You already know. Clear? But simple. You know that nitrogen is belongs to 6 group. 6 group means what it is one. NS2, 2s2, 2p4. 2p4 means here 2 electrons are there, and the p orbital how many electrons are there? 1, 2, 3, 4. So oxygen involved in means these are 2 unpaired electrons are there. So oxygen forms how many bonds here? 2 covalent bonds. Here 2 covalent bonds. 1 electron oxygen give and hydrogen give 1 electron, and they will form 1 bond. Oxygen give this 1 electron, hydrogen give 1 electron, and it forms 1 bond. So these bonds we will call as a covalent bond. Clear? Now plus if it is coming any electron deficient compound here, I am getting what is any electron deficient compound. Clear? So what will happen here? And this, you know, it is having one pair of electrons here, and this pair of electrons it donates to the hydrogen. So then what will happen? You see, you will get, and here hydrogen, and here oxygen, and what is the charge? Because oxygen is losing electron. Losing electron means which charge it will gain? Positive charge. And here what it is? H. It is gaining electron. Already gaining electron means which charge it should get? Negative charge. But already hydrogen is having which charge? Positive. Negative charge and positive charge present on the same atom. It will be charge will be neutralized. So that's why you will get this is the compound. Or it simply can be written as what is here? H and H and positive charge on this. Clear? This is what we will call here negative bond. Now you see, and it is donating pair of electrons. So that's this molecule we will call as a donor, and this is accepting the pair of electrons. So this we will call as a acceptor. This we will call as what is here acceptor. The atom which donates the pair of electrons is called as a donor atom. The atom which accepts the pair of electrons is called as a acceptor. So this is what it is here dative bond. And also I will explain one or two example, then you will get the. So another example I will take here, NH3, clear? Another one is boron trifluoride, BF3, clear? You know that nitrogen is forming how many bonds over here? Nitrogen is forming 3 bonds. What is the covalency of nitrogen? 3, clear? So if nitrogen forms 3 bonds, then it is having one lone pair of electrons. You already know nitrogen 2s2 2p3. 3 unpaired electrons are participated in the bond formation and they form 3 bonds, and 2s2 is non-bonded electron, that is lone pair. Clear? Boron, you know here boron is boron atomic number, what it is? 5. 5 means what we can write here? 1s2, 2s2 and 2p1. How many valence electrons are there here? 2 valence electrons are there. Means here there are 2 electrons in this one. That is 1 electron. Means how many bonds it has to form? 1 bond, but it is forming how many bonds? 3 bonds. Means this is in ground state. In the excited state, one of this electron will jump here. Now how many unpaired electrons are there in the valence shell? 3 unpaired electrons. So that's why it is forming how many bonds, man? 3 bonds. It is forming how many bonds, man? Here? 3 bonds. Is there any non-bonded or lone pair of electron here? No. So that's why it doesn't have any lone pair of electron. But you see, empty orbital is present here. Clear? So that's why if you see this nitrogen, in this one donor atom is there. Donor atom, remember the central atom always should attain the octant in the what it is here formation of dative bond. That you have to remember in your mind. Clear? So now you see, this is donor atom, and here 1 bond, 3 bonds are there, 6 electrons, and here 2 electrons, 8 electrons. Clear? It is a octant, and it can donate the electrons to others. Why? After donating these electrons also, those electrons are shared by both the atom. So that's why it won't lose its octant. So it donates. But here, how many electrons are there? You see, 3 bonds are there. 3 bonds means how many electrons? 6 electrons. So it is 2 electron less for the octant. So that's why what will happen here? It needs 2 electrons, and this NH3, it gives 2 electrons to the what it is here? Electrons to the boron and forms 1 coordinate bond. Clear? So now what we have right here? Hydrogen, hydrogen and hydrogen, and these electrons are shared by both the atoms here. Fluorine, fluorine and fluorine. Clear? These electrons are belongs to both the central atoms. Now, how can we write this? We can write that with the what it is here, dative bond. This is dative bond between the what it is here. Means you see, only one nitrogen atom is donating electrons, but nitrogen and boron both are sharing the electron. Now both retain the octet. Clear? So these are about what it is here. Examples. So many examples are there, and very important. Sometimes in the competitive examination, they will give some compounds. Which compound is having the dative bond? Clear? So they will give here. So what you have to do, I will say simple trick here. Suppose I will write H2SO4. Clear? So what it is here? H2SO4. Clear? If you write the structure of H2SO4, first we have to write the Lewis dot structure. Clear? Otherwise, you know, if you write the structure, common structure for this, you know, H2SO4. What is the H2SO4 here? S double bond O, S double bond O, OH and OH. Previous I already mentioned, which exceeds the extended octant rule. Clear? So there I have given here H2SO4. Now in this compound, they will ask how many coordinate bonds are there. Clear? So I already mentioned the central atom should attain the octant. The central atom should attain the what it is here? Octant. If you see, this is central atom is there. In this central atom, around the central atom, how many electrons are there here? How many bonds are there? Check it. 2, 2, 4, 5, 6. 6 means 6 into 2. 1 bond formed by the 2 electrons. Totally, how many electrons are there? 12 electrons are there. So that's why you have to make and 8 electrons to the central atom. So how I will do means, and you know single bonds we cannot break, but what I will do, I will write in this way. OH, this I will write like Lewis dot structure, like I will write. Clear one? So here OH, clear one? Here what it is one? O and here O. If I write like this, then what happens? You see one? Central atom is having how many electrons here? 8 electrons. Central atom is having what? 8 electrons. Now, and these bonds, because oxygen has to form how many bonds? 2 bonds. Here oxygen is forming how many bonds here? 1 bond. Clear one? Remember always, nitrogen should form how many bonds? 3 bonds, because covalence of nitrogen is 3. Oxygen covalence of how much? 2. It has to form 2 bonds. This oxygen is C, and this oxygen is forming 2 bonds here. Oxygen is forming 2 bonds, and here also oxygen is forming 2 bonds. But here oxygen is forming how many bonds here? 1 bond. 1 bond means that bond should be what is one dative bond, and this is the dative bond. Here you have to write in this way. So how many dative bonds are there in the H2SO4? 2 dative bonds are there. Clear? If you write the Lewis dot structure, you will get in this way. 2 dative bonds. Oxygen is forming in this molecule 1 bond means what is a dative bond. Clear? If you write the Lewis structure, you will get in this way. Lewis structure, if you write, you already know how to write the Lewis structure. If you write the Lewis structure, you will get the and OH and here OH, and between the oxygen and sulfur you will get single bond. And single bond is a dative bond. Got my point here? In the same way, sometimes what they will ask here, SO3. What it is here? In the SO3 molecules, how many dative bonds are there? First write as usual. And sulfur is the central atom. That means oxygen forms how many bonds? 2 bonds. So that's why there will be a 2 bonds here. Oxygen is making 2 bonds. How many total bonds are there here? 6 bonds are there. But sulfur means you have to see central atom should attain the octet. But it is how many electrons are there around the central atom? 12 electrons are there. So that's why make this one as a octet to attain the octet. So what I will write this molecule? I will write one. I will put here double bond O, and another one. What I will do? I will write O and here O. Then it attain the octet or not? Yes. Here how many are there? 2 and 3, 4. 4 means how many electrons are there? 8 electrons are there. 8 electrons means it attain the octet or not? Yes, it attain the octet means it is. So oxygen is forming how many bonds here? 2 bonds. Doesn't matter here. And here oxygen is forming how many bonds? 1 bond. 1 bond means it should be a dative bond. Here also what is 1 bond. So it is a dative bond. How many dative bonds are there in the SO3 molecule? 2. That is. You have to write them the structure like this. Or otherwise, you have to write the Lewis dot structure. Then also you will get in the same way. Suppose if I write the Lewis dot structure for SO3 molecule. See how can I write here? Lewis dot structure SO3 molecule. Yes, sulfur. Sulfur means what it is? Oxygen, sulfur belongs to which group? 6th group. So that's why I have to write the 6 electrons, valence electrons. And the oxygen also 6 into 3. So 6 plus 18. How many electrons are there? 24. Write the sulfur is the central atom. Clear one? And here write the 3 oxygen atoms. First of all, you have to put the 1 pair of electrons between the central atom and outer atom, means terminal atom. After that, you have to complete the octet for which one? Terminal atom. So now I will write like this. Clear one? So here I am writing like this. See how many electrons are you see. So total 24 should be there. And here 1, 2, 3. Each oxygen 3 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 means how much? 24 electrons. So 24 electrons I have. Use it now. But this is attained octet, and all oxygens attains the octet. But sulfur not attain the octet. Sulfur you see one here. So how many electrons are there? 1, 2, 3, 6 electrons. So that's why any one of the oxygen electrons, clear one? So here already 2 electrons are there, and I will write another 2 electrons from the oxygen. But here I will keep all the electrons like this. Clear one? So here this is clear. So now this is the what it is structure. If you write here in the bond formation. Like what I can write here, sulfur is there. Here 2 bond pairs are there. There is a 2 double bond, and here one bond is there, so it is a oxygen, and another one bond is there, it is a oxygen. Shall I write like this? So oxygen is forming which bond, my dear? Single bond. Single bond means what it is? It should be a dative bond. You see, sulfur is giving electron, means here electrons are there. Clear, my dear? So it is which bond, my dear? It is a dative bond. Clear? So like that, you have to write the Lewis dot structure, or if you know the structure, if it is extended octet, then remove some bonds to maintain the octet for the central atom, then which bonds are single bond for the oxygen, and those are what we will call here dative bonds. Clear? So this is about the what it is here dative bond, very important for your competitive examination and peer examination also. So now we have completed all the three types of bonds. One is a covalent bond, ionic bond, and a dative bond. Now we have to discuss some bond parameters. The first one is here bond length. Clear? What is the bond length? Clear? So the distance between the center of the bonded atoms is called as a bond length. Clear? So what is here definition? The distance between the centers of bonded atoms is called as a what it is here bond length. Clear? So write the definition here. The distance between centers of bonded atoms is called bond length. Bond length. It is denoted by which one here? D. Yeah. What is the bond length? Suppose two bonded atoms are there, and A and B atoms are there, and those are bonded. Clear? So then this is one atom, another atom is this. Clear? One is a cation, and always anion size should be greater than cation size. Now, if I take here, this is atom A and this is atom B, they bonded. Clear? So there is a bond between the A and B. Clear? So what is the bond length here? That how we will measure the centers of the two atoms here, bonded atom, and this distance we will call as a bond length. The distance we will call as what is here? This is the distance. This is we will consider it as a D. That is the bond length. Clear? If you take and bond radius, means this is the we will write radius of atom A, and this is the radius of atom B, RP. This is what it is here, radius of atom A, and another one is what it is. This is exactly. This is radius of A and radius of B. Now this is the bond length. Clear? See now what is the distance between the centers of the two bonded atoms, and this we will call as a bond length. That is denoted by which one here? D. Clear? Suppose if I take what is the distance bond length here, so bond length is equal to D. What is bond length? D is equal to what we can write here? RA plus RB. Radii, and radii of A and radii of B, that is what it is. This is the bond length. Clear? When we have to consider this, we have to consider and electronegativity of A and B are very, very less. Clear? So electronegativity of A and B are very less. Very less. Clear? So this is bond, what is length. Clear? If electronegativity difference is more, then how to calculate the bond length is D is equal to Ra plus Rb minus 0.09 and Xa minus Xb. It is what it is here, electronegativity values. Here Xa and Xb are electronegativity values in angstrom. Here Ra and Rb are in angstrom. We have to take this one. Clear? So what is that? I will discuss. Clear? So this is. And if I take here for homoatomic molecules, homodiatomic molecules, diatomic molecules. If you take the homodiatomic molecules, means what is the homodiatomic molecules, Maria? Both the atoms are, bonded atoms are same. Same means what I can write here? I will write here. For this is, atoms are same. This is also A and this is also A. Clear? Both are which one? Chlorine like. Clear? So it is also atom A and atom B. And now what is the bond distance here? Bond distance or bond length we can write here RA plus RA, radius of, here what it is, this is RA and this is also what it is, RA. Previous it is RA and this is RB. Got my point here? So RA plus RB. Then what we can call D is equal to 2 into RA. So if I want here covalent radii of A, then what we can write here? Covalent radii of A is equal to what we can write from here? RA we need here. Covalent radii of A means RA. RA means what is bond length divided by 2. Bond length divided by what is 1? Clear? And very important another one is this bond length is expressed in terms of angstrom or picometer. Clear? So bond length is expressed. Bond length is expressed in terms of angstrom. What we will call this is angstrom denoted by A naught R picometer. R what it is here? Picometer. Picometer means what it is? Symbol is here. Clear? So this is about what it is here? Bond parameter. Clear? Bond length means the distance between the centers of two bonded atoms is called as a bond length. And bond length D is equal to sum of the radii of two atoms, RA plus RB. Electronegativity of A and B are very less. If electronegativity of A and B are more, then you have to use this formula RA plus RB minus 0.09 into XA minus XB. XA minus XB means what it is? Electronegativity value of A and here electronegativity value of B. Radius of A and radius of B. When we have to use this formula, if RA and RB, radius of A and radius of B are in angstrom. Clear? So you have to use this formula. So if homodiatomic molecule means I have taken here two different atoms. If both atoms are same, then bond length is equal to sum of the radius of A plus sum of the radius of A and radius of another molecule also A. So D is equal to 2A. So that's why bond length is equal to what it is? 2 into RA. If we want here covalent radii or radii of RA, then bond length divided by 2. And it will be expressed in terms of what it is? Angstrom, and the symbol is A naught and picometer. Now factors, we will discuss which factors affecting the bond length. So now we have to discuss about factors affecting the bond length. So the first one is size of atoms, bonded atoms. Clear? So size of atoms. Clear? So as the size of atoms increases, automatically bond length also increases. Clear? So here size of atoms increases. Size of atoms increases. Bond length also. BL means what is bond length also increases. Clear? If I take here one simple example and I will write here HI, HBr, HCl and HF. Clear? See now, I will write the first one and last one. If I take here fluorine, bromine and iodine. If you are moving from fluorine to iodine, size increases. So hydrogen size is same. Here hydrogen size is here and fluorine slightly it is larger than what it is here. You know. So what is the bond length here? This is the bond length. This is the bond length. Clear? Now you see here. So here it is a hydrogen and here what is there? It is a iodide ion. Clear? So this is the center. So where the bond length is long. So here bond length increases. From here what it means? Atoms are, small, bond length also will be small. If atoms size are bigger, as the size of atoms increases, then automatically bond length increases. So what is the bond length atom? This is the bond length atom. Clear? In the same way, and second one, Second one is here multiplicity of bond. Clear, ma? So multiplicity of bond. Clear, ma? So what is the multiplicity of bond? Clear? And multiplicity means what is the number of bonds. When number of bonds increases, clear, ma? Automatically bond length decreases. Clear, ma? As multiplicity of bonds increases, multiplicity of bonds increases, clear, ma? Bonds increases, then automatically what will happen now? Bond length decreases. You have to write, don't put the arrows here like, clear, ma? You have to write multiplicity of the bond increases, bond length decreases. Clear, ma? Simple example I will say here, and you know, if you take here C bond, RC double bond, RC triple bond. Clear, ma? You know that in this one, when only single bond is there and bond length will be longer compared to the double bond. Here bond length is 1.54 angstrom and this is, and here 1.34 angstrom and here 1.20 angstrom. Clear? See, as the number of multiple bonds increases, here one bond, two bonds, three bonds, as multiplicity means number of bonds, multiple bonds. Clear? So increases, automatically bond length also, bond length decreases. Clear? This is the another one concept. And third one is here type of hybridization. Type of, this is not yet done. Clear? So but just you remember when we discussed about the hybridization, in this chapter only we will discuss hybridization. That time we can clearly understand. Type of hybridization. Type of hybridization. Clear? If I take suppose same here only, C double bond C and here C triple bond C. Here carbon hybridization is sp3, double bonded carbon means sp2 and triple bonded carbon, both the carbon, here sp2. Clear, ma? As the S character increases, automatically bond length decreases. Clear, ma? S character means how to calculate S character here? Here, totally one S arbitol, 4 p arbitol. So 1 by total how many arbitols? 3 plus 1, 4 into 100. So how much for here? 25% S character is present here. It says S character. Here S character how much, ma? 1 divided by total how many? 3 into 100. So here almost 3 is a means 33.33% you will get. And here 1 S and 2 total arbitals are there into 100. How much more here? 50% S character. S character here 50%. S character here 33%. S character here 25%. You know that triple bond is there. Automatically from the single bond to triple bond length decreases. So here only sp3, sp2, sp hybridization we will call. That we will call as the types of hybridization. Clear, ma? Types of hybridization. As the S character increases, clear, ma? Automatically what will happen, ma? Here bond length decreases. You write that one. As S character increases, bond length decreases. So these are the main factors which affects the what it is here, bond length. So next bond parameter is bond enthalpy. Bond enthalpy or bond dissociation energy or simply bond energy can also be called. Clear, ma? So what is bond enthalpy? Clear, ma? So here the amount of energy required to break the bond between the atoms. Clear, ma? Between the atoms, particular bonds. How many bonds here means the amount of energy required to break the 1 mole of bond of particular type. Any type of the bond, particular type of the bond, 1 mole of the bonds to break. Clear, ma? How much energy is required, and that energy we will call as a bond energy or bond dissociation energy, or we can call bond enthalpy. Clear, ma? So after then breaking, after bond breaking, and those atoms has to separate in form of gaseous atoms. Clear, ma? It is, and that we will call as a bond enthalpy. Clear, ma? See the amount of energy required to break the 1 mole of bond of particular type in order to separate them into gaseous atoms. Into separate them into gaseous atoms is called as a what it is here? Bond enthalpy. Clear? And it is expressed. It is expressed in kilojoule per mole. Kilojoule per what is here? Mole. Means 1 mole of the bonds to break, how much energy required, and that will be called as a bond enthalpy. Clear? So that's why kilojoule per mole. Clear? So for suppose if you take here for diatomic molecules, bond enthalpies are equal to their bond dissociation energies. Their bond dissociation energies. Simple. If I take here diatomic molecule like H2. H2 is there. Clear? H2 means how it will be there? H and H. Clear? To break this bond, after breaking this, they should convert into what it is? Atoms. How many atoms are there? I break this bond. 1 hydrogen atom, 1 hydrogen atom, 2 hydrogen atom, and this for this one, this will be called as a atomization energy. Means to break the bond to convert it into their atoms is called as a atomization energy. And how much energy here is? It is almost 435.8 kilojoule per mole. Clear? For this diatomic molecules, there is no problem. What is the bond dissociation? Bond enthalpy are automatically equal to their bond. Means what is the bond energy is only bond dissociation energy. But the problem is here for polyatomic molecules. Clear? For polyatomic molecules, the bond enthalpies are usually what it is here? Average values. We have to take the average values. So for what it is here? For polyatomic molecules. For polyatomic molecules. For polyatomic molecules. Clear? Bond enthalpies. Bond enthalpies are usually what it is here? Average values. Average values. You have to take the average values of bond enthalpies. Why we have to take average values of bond enthalpies? Clear? Why? Because suppose I will write here H2O molecule. What it is here? H2O molecules. What is the H2O molecule here? Water. This is the water. Clear? So in this one there are two OH bonds. OH bond and OH bond. Clear? First I will break one OH bond. Clear? Then here H plus what will be there? OH. For this one just assume the energy required is so x kilojoule per mole. How much required here? X kilojoule per mole. Clear? And now I have not totally break all the bonds here. Only I break the first bond and another one what it is another OH is there, and this bond also I have to break. To break that bond also I need some energy, and how much that energy is, and we just assume y kilojoule per mole. Why it is here also you may ask, here also OH bond I am breaking, here also OH bond I am breaking. How much energy required for to break this OH bond? The same energy should be required to break this bond also, but not. Why? Because it is H2O molecule, but here what it is? OH molecule. Molecule totally different. Automatically bond dissociation energy also different. So that's why what is the now bond enthalpy or bond energy for the H2O molecule means I cannot say x kilojoule per mole, I cannot say what it is here y kilojoule per mole. So what I have to take here? I have to take average bond enthalpies. Average bond enthalpy I have to take. Average bond enthalpy is equal to what I can write? X plus y divided by 2 kilojoule per. So this is the bond enthalpy of what it is here, water. So now we will discuss factors affecting the bond enthalpy. So here factors affecting the bond enthalpy. First factor is here size of atom. What it is here? Size of atom. As we have discussed the previous one, just now only we have discussed. As the size of atom increases, the distance between the nucleus of the bonded atom also increases. Bond length increases. That is only. As the size of atom increases, bond length increases. If bond length increases and bond strength decreases, means that bond can easily break. Clear? Simple example I will take. Take the one stick, long stick. Clear? Same stick you take very short. Clear? And take the long stick and we can easily break that stick. Why? Because the length is longer. Clear? So that's why we can easily break that one. Same stick, take the small length of the stick, then what will you? To break that you have to put lot of energy. We cannot break easily, right? So that's why this is also same thing. Bond length increases, we can break that one easily. Means bond length increases, bond strength decreases. Clear? So that's why as the size of atoms increases, bond length increases, bond strength decreases. Means bond strength decreases means what? Bond enthalpy decreases. To break that bond, we need not to put much energy. That we will call as what? Bond enthalpy. That is clear here. As the size of bonded atoms increases, then what will happen here? Bond length increases. If bond length increases, bond enthalpy or bond strength, bond enthalpy decreases. Bond enthalpy, what it is here, decreases. And if I take the simple example, previous only I mentioned here, one is Hi, another one is what it is HCl and HBr, and another one is HCl and HF. Clear? What is the bond length order here? This is the bond length order. So now, what should be the bond enthalpy or bond energy? Bond length increases, bond strength decreases. So Hi is less than, HBr is less than, HCl is less than, HF is less than. See, this bond length is very short, so that's why the bond between the hydrogen and chlorine is very strong. If its bond is strong and bond, to break that bond you have to put a lot of energy. That we will call as a bond enthalpy. The energy required to break the bond. Clear? This is. And the second one is multiple bonds. Clear? Multiplicity of bond. Multiplicity of, which one here? Bond. Multiplicity of bond. You know, as the number of bonds increases, automatically bond strength increases, because the number of bonds increases. One bond is single bond is there, next single bond and double bond, two bonds are there. Breaking two bonds and breaking one bond, which is very easy. Breaking one bond is very easy. Clear? So that's why as the multiplicity of the bonds increases, automatically bond enthalpy, bond energy increases. Clear? So suppose if I write here multiplicity of bonds increases, multiplicity of bonds increases, automatically bond enthalpy or bond energy also increases. See, simple example. If I take there is a bond, single bond is there between carbon and carbon, but here double bond and here triple bond. Which bond can easily break? One bond can easily break, but here how many bonds you have to break? Three bonds you have to break. To break the three bonds, you have to supply much amount of the energy. That we will call as a bond enthalpy. So this is bond enthalpy. Clear? Next one, third one. Number of lone pairs. Third one, what the factor affects is number of lone pairs present on bonded atom. Present on atoms. Clear? So this is also one criteria and which affects the bond enthalpy. Clear? Simple, I will write here. There is a C double bond C. I am taking here ethane molecule. You already know what is this one? Ethane molecule. In the ethane molecule, C double bond C is there. In the nitrogen, carbon nitrogen. Nitrogen means this is in nitrogen. There is a one single bond is there. I am talking about only single bond character of nitrogen. Clear? In the oxygen, this is oxygen means one double bond. I am writing only one bond. And the fluorine, this is the fluorine in F2. Clear? So I am talking here double bond is, triple bond is there, double bond is there, but I am not talking about the double bond and single bond. And here I have taken only sigma bond for all cases, single bond, and where because in one bond if I take two bonds here, automatically to break the double bond required more bond energy. So that's why I am taking all the single bonds here. I am comparing. Got my point here? See now. In this case, you know carbon forms how many bonds here? Carbon is forming 4 bonds. Carbon is forming how many bonds? 4 bonds. Carbon is forming 4 bond means carbon will have any lone pair of electrons? No. So that's why there is no lone pair of electron. But nitrogen will have, nitrogen is forming how many bonds here? 3 bonds. So that's why nitrogen will have 1 lone pair. Oxygen, when it is forming 2 bonds, it will have the 2 lone pair. And fluorine is having 3 lone pairs. You already know how I am writing this. Clear? So nitrogen is 2s2, 2p3, right? So this is 2s2, 2p3. How many single electrons are there? 3 single electrons. So that's why it is forming 3 bonds between the nitrogen and nitrogen. 1 lone pair is there. If you take oxygen, oxygen means how many? 4. So this is 1 electron and 1 electron. Oxygen is forming 2 bonds. 2 unpaired electrons are there. It is forming 2 bonds. How many lone pair of electrons are there? 2. If I take here fluorine, 5. Clear? 1 bond is there. Into 1 unpaired electron is there. It will form 1 bond. So how many lone pairs are there? 3 lone pairs. That is only I have said. Clear? So now, if you see here, in this case, which one will have highest bond dissociation energy? Clear? Simple. You know that on the carbon there is no lone pair, but here what is happening? 2 lone pairs are there. Here 1 lone pair and another 1 lone pair. If lone pairs are there, lone pairs means what is electrons only. Here also electrons are there. Here also electrons are there. Electrons means having which charge? Negative charge. Here also negative charge, negative charge. Same charges always repel each other. So that's why here electrons and here electrons and very close to each other. So that's why they repel each other. When they repel each other, to avoid that repulsion, this nitrogen bond length is increases. So then what will happen over here? And bond length increases means automatically bond strength, decreases. Means bond enthalpy values also decreases. To break this bond, we can easily break this bond. So that's why bond enthalpy decreases. But here only 1 pair and 1 pair repulsions. But here how many are there? 2 pairs, 2 pairs. More repulsions. More repulsions means to avoid that repulsions, 2 oxygen atoms move away from each other. Bond length increases, automatically bond enthalpy decreases. But here 2 repulsions are there. This is repulsion and here this is repulsion. But here how many repulsions are there? 3 lone pairs are there. More the lone pairs here, more the repulsions, and bond length automatically increases and bond strength decreases. So which one is having the more which one is having the high bond enthalpy? This is after this because as we are moving from the nitrogen to fluorine, repulsions are increases. Clear? So that's why more the repulsions, and then what will happen? To avoid the repulsions, fluorine atoms move away from each other. So bond enthalpy is decreases. So this is what it is, factors affecting the what it is bond. So next concept is here. Next bond parameter is bond angle. Clear? What is the bond angle means? So we will write the structures. Clear? And we will represent the lines. Lines lines represents the what it is bonding electrons. And bonding electrons where they are present. Electrons are present in the orbitals. Clear? Means the angle between the bonded orbital means orbitals, that we will call as a what it is here bond angle. Yeah, so this is the angle between the lines. The lines representing what it is here direction of the bonds. Means what it is? These are orbitals. The angle between the orbitals, because orbital topic we have not covered here, so that's why I am not mentioning. I am not discussing much about this. Orbitals containing bond electron is called as a what it is here bond angle. Clear? So these are the lines you see. This is the molecules. And these are the lines. These lines representing for what it is direction of the bond. And there, what is the angle here? Bonds. This angle. What are it made? The angle you can take these 2 lines, or you can take these 2 lines, and that is the here if you take 109.28 minutes. These are the bond angles. Clear? So it is expressed in degrees, minutes, and what it is here seconds. Clear? If you take here CH4, clear? The shapes all we will discuss later, not required here. So what is the bond angle here? 109.28 tetrahedral structure here. This is, you see, nitrogen. Nitrogen means ammonia, NH3. NH3, what is the bond angle here? This is the bond angle. That is only the angle between the lines representing the direction of bonds is called as what is the bond angle. 107. In the water, what is the bond angle? 104.5 degree. If you take here BCl3, BCl3 is trigonal planar. Clear? Trigonal planar is triangle. Triangle, what is my angle here? 120. BCl2 linear. Linear means what is the angle here? 180. Means you have to take between the lines angle you have to see. We have two lines only, between the lines what is the angle here? 180 degree. So this is about what is here? Bond angle. So factors, which factors affects the bond angle means the first one you see, we can say lone pairs. Lone pairs you can put here factors affecting bond angle. Clear? Bond angle. Factors affecting what is here? Bond angle. Clear? So what is the first point here? Factors affecting the bond angle? Lone pairs. Clear? Lone pairs on atoms. Lone pair on atoms. Clear? Affects bond angle. Bond angle. Clear? See why? Because I am saying here, in this one carbon is having any lone pair? No, 109.28 degrees. Nitrogen is having one lone pair. So it is, you see, bond angle is decreasing. If more lone pairs, and here bond angle is another decreasing. So this is the first point is lone pairs on the atom affects the bond angle. Mainly what is what decreases. And now second one. Sometimes they will ask and write the bond angle order for these molecules. Clear? So like I have written here NH3, same I will write here NH3. Clear? H, and here there will be a hydrogen, and here there will be a hydrogen. Clear? See now, in this case, how to decide here? I am not writing here exactly what is the bond angle. What happens bond angle if you are moving from the NH3 to BiH3? That I wanted to say. Clear? See in this case. Now if you take nitrogen and hydrogen, which one is more electronegative here? Nitrogen is more electronegative. Nitrogen is more electronegative means these bonded electrons are very close to which one? More electronegative atom? That is nitrogen. Here also the bonded electrons are very close to what is here? Nitrogen. Then what happens? You see, these bond pair electrons are coming very close to each other. And here what will happen? There will be a repulsions between these two bond pairs. This will be called as a bond pairs. Repulsion because they are very close to nitrogen. So that's why here bond pair and nitrogen is here. One bond is like this and this is. So electrons are very close to nitrogen. Then what will happen? There will be a repulsion between the electrons. To avoid that repulsion, this bond will move this side and this bond will move this side. Then what will happen now? First of all, like this, due to the repulsions, they are moving away from each other. Then automatically what will happen? Bond angle increases. And maximum bond pair repulsions will be observed in NH3. If you take now last one, I will take Bi is 3. Bi. Here also there will be a one hydrogen, and here a hydrogen, and here hydrogen. If you are going to nitrogen to bismuth, nitrogen to what it is? Bismuth. As you are moving from the top to bottom or along the group, electronegativity decreases. So that's why bismuth and hydrogen, almost bismuth it will show the metallic character. So that's why, and hydrogen is more electronegative than the bismuth. So these bond electrons are near to which one? Hydrogen. Then what will happen? You see, and these bond pair electrons are away from each other. But here bond pair electrons are close to each other. When they are close to each other, repulsions will be more. To avoid the repulsions, these two bonds will move away from each other. Bond angle increases. But here you see, and in this case, the distance between the bond pair is large. There will be no repulsions. No repulsions means what they will do? They will come close to each other till they experience the repulsion. Then what will happen? This bond will come towards this and this bond will come towards this. Both are friends here. Then what will happen? They are coming close till they experience the what it is repulsions. So that's why bond angle what will happen? Decreases here. Clear? That is the concept. Clear? Means what it is? As the electronegativity of the central atom increases, then bond angle also increases. Clear one? That is, so what is the bond angle order here? This is what the point you have to write here. Second one, as the electronegativity of central atom increases. Clear one? Bond angle increases. That is the second one. Clear one? Now third one, you see, in this case you see now central atom is same. Now outer atom means terminal atoms are different. Now I will write here nitrogen, iodine, and here also what it is now? Iodine. Clear? And now in this case what you have to write? Fluorine, and here fluorine. Clear? First point you might have to copy. So now nitrogen, fluorine, and fluorine. Here also central atom is same. Here what is the atom? Here nitrogen. Here it is iodine, and here it is iodine, and here it is iodine. Okay. Now you see nitrogen and iodine. Which one is more electronegative? Nitrogen. So that's why this bond pair electrons are which one? Close to nitrogen. But here if you see nitrogen and fluorine, which one is more electronegative? Fluorine is the most electronegative in the periodic table. So these bond pair electrons are close to which one? Fluorine atoms. Clear? See now, here these two electrons are very close to each other. Very close to each other means what will happen? Repulsions. When they are repelled, and to avoid that repulsions, this bond try to move this side and this bond try to move this side. Then what will happen? Bond angle increases. But here in this case, and you know the distance between the two bond pairs are very large. Clear? So they will not experience any repulsions here. So they will not experience. So that's why they will come to close each other till they experience the repulsions. Once they experience the repulsions, they will stop there. Means this bond is moving this side and this bond is moving this side till they experience the repulsion. Then automatically bond angle will decreases. Clear? So that is, and in this case, bond angle. Clear? So what I can write here? As for the same central atom molecules, if you same central atom of the molecule and terminal atoms electronegativity decreases, bond angle increases. Clear? So write that point here. Third point we have to write. What is the third point? So here for same central atom molecule, when electronegativity of outer atom decreases, bond angle increases. Bond angle, what happens here? Increases. So this is about the concept of what is here? Bond angle. Okay. So last bond parameter concept is here bond order. Clear? What is the bond order means? The number of bonds present between the two bonded atoms in a molecules. Clear? That will be called as a bond order. How many bonds are there between the two atoms? That will be called as a bond order. Right here, number of bonds between two bonded atoms in a molecule is called what it is not here? Bond order. Is called what it is not here? Bond order. Suppose simple I design hydrogen and hydrogen, H2 molecule, N2 molecule, or O2 molecule, what it is not? Oxygen and oxygen. And nitrogen, how many bonds will be there between the nitrogen and nitrogen? 3. And carbon monoxide, there will be 3 bonds. Clear? So this is. So what is the bond order? Bond order means what? Number of bonds between the bonded atoms. Here how many bonds are there? 1. So what is the bond order for these molecules? For first hydrogen 1. For this one, how many bonds are there? 2. So bond order is 2. And here bond order is 3. And here also bond order is 3. Clear? So we know the concepts here. As the bond order increases, automatically what will happen? Bond enthalpy increases. That is one concept here. Clear? So very important. Bond order increases, then what will happen? Bond enthalpy also. Bond enthalpy or bond energy. Bond energy means what? To break the bond, how much energy is required? That is bond energy. Bond enthalpy increases because to break the one bond and to break the 3 bonds. To break the 3 bonds, you have to supply a lot of energy. That energy will be called as a bond dissociation energy or bond energy or bond enthalpy. Clear? So another one is here, bond order increases. As the bond order increases and bond length decreases. Clear? Bond length decreases. Bond length decreases. I already mentioned here. And here 3 bonds are there, bond length will become shorter the bond. Greater the, simply I can say greater the bond order and shorter will be the bond length. Greater the bond order, greater is the bond enthalpy. Clear? So greater the bond order and shorter will be the bond length. And very important here, isoelectronic species will have same bond order. Clear? What it is here? Isoelectronic species. Isoelectronic species have same bond order. Clear? Same bond order. Suppose they will ask here. They have given F2 and O2 2 minus. Clear? So, what is the bond order for these 2 molecules? They will ask. What is the bond order for these 2 molecules? You know, F2 means we can write here F and F. You can simply say, yeah, here one bond is there, so bond order is 1. But what about this? Clear? That's why. Here, how many valence electrons are there? You see, how many electrons are there if you count the electrons in the fluorine? Fluorine belongs to. Fluorine is having 9 electrons. 9 into 2, how many more? 18 electrons. Not the valence electrons I am saying. I am saying about the electrons. Isoelectronic species. Atomic number 9. 9 means 2 fluorine. 18. Oxygen atomic number 8. 8 into 2, 16. Minus 2 means you have to add 2 electrons. Not how many more? 18. So this O2 minus also having the bond order how much more? 1 only. If you don't know the structure, you can simply say bond order 1 because it is both are having same electron. Same electron species we will call as isoelectronic species will have always same bond order. So that's why if I write this is O and O, this is minus 1, this is minus 1. O and O, O2, minus 1 and minus 1, minus 2. What is the bond order here? Single bond. So it is a 1. In the same way, another molecule I will say, if I take some examples here, N2CONO plus. N2CONO plus. Clear? So these all are isoelectronic species only. Nitrogen how many more? 7 into 2, 14. Carbon, you know 6 plus 8, 14. Nitrogen 7 and oxygen 8. Atomic number is good number of electrons. Atomic number of nitrogen is 7, oxygen is 8, 15. Plus 1 means remove 1 electron, 14. All are having what it is? Same electrons. So that's why this all will be called as a isoelectronic species. So you don't know. You know nitrogen. Nitrogen what it is? There will be a triple bond. And triple bond means what is the bond order here? Bond order is here 3. Automatically CO also will have the bond order 3 and NO will also have the bond order 3. NO plus. Clear? If you don't know structure also, if nitrogen you know, and automatically they will also have the bond order will be 3. And this is about what it is here and bond parameter.